Well, this package is alright. Let's get into it. This, I believe, is a piece of test gear for me to potentially fix. Don't know. So I'll figure out how to get into it because they've got a kind of weird box set up, I think. So as always, I told them to package it really well. I said 100mm of thick padding. Well, I do got thick padding. It's not 100mm. What's that? 30mm. But they made an effort. You know, they've actually done it. Protected the front panel. It's not exactly what I requested, but I think it's fine. I'm going to give them a thumbs up for that. Defpom approved. Cut it around the knobs there. Tell them to protect everything. Well, this is what we got. Sencore. It's the LC53 model. Switches feel a bit gummy. So does that one. Yeah, it's almost sticking in. Yeah, I think this needs a really good clean. Okay, it's the outside's fairly dirty. Got a cable on the back here, which has got some damage to it. It's like soldering iron damage, maybe. Don't know. Definitely got hot. But this is AC anyway, so I need to look at converting this thing to be suitable for New Zealand because we need 240 volts here. I don't know if it can be converted. I don't know. But, it's a nice cable holder actually, the way it's designed. Balance. Something here which I can't read because it's destroyed. Another adjustment over here for something. There's a little clip holder thing there, another holder here. So it's accessories which are supposed to be which are missing. I think there's like a button thing which goes on the front, so if you want to do a leakage test, you bring this down, which is also really stiff by the way, and you just press it with that plunger thing, just holds that button in. I mean, that's not a big deal. I can make something for that. It's not exactly hard. Let's open it up and have a look, see what's inside. But I mean, the outside's a bit dirty, a bit yellowed. I don't know if it's nicotine. It feels a bit sticky too, so maybe it's nicotine. Yeah. I can't smell anything, so not too bad, but old. I'm going to open it up first before we power it up. Just found this under here. It says run 40 underneath it. It's got maybe a serial number there too. Just found this little pocket. Didn't even know this was there. But we've got a pull out. Nice. It's all intact. That looks really good. Notice I don't have the original leads to go with it, but well, let's go with these screws. These are the only screws I can see, so it's assumed the back panel has to come off, and we'll go from there. This isn't exactly the unit I wanted. I mean, I wanted the LC103, and I was really close to getting one a while ago, and I purchased it and it's posted, and it got part way here, and then it got turned around by the shipping company and sent back to the seller. And it was a mint condition one. It looked beautiful. At least it did in the pictures. You know what note you're going to really get, but it all looked like it's all complete and it looked really good. It's like new in box kind of thing. And unfortunately, that fell through. I got the money back at least. But yeah, that's what I really want to get is a LC103. Oh, there we go. That whole thing slide out, does it? Yes, it does. Right. And that's very dirty in there. Oh yes. So there's the casing, just slides out of that. Look at the state of that. Dust. Dust. This really needs a good clean. That is, yeah, very, very dirty. There's a fuse inside here, which looks intact. This is not some kind of weird special fuse. It's a special fuse holder, not a special fuse. So I can get to a switch mechanism to lubricate them, that's nice. But the main thing I'm trying to sort of suss up right now is, figure out right now is changing this to 240 volts. If it can be done or not. The transformer's got multiple taps in the car over here. But yeah, the main thing right now is it's really, really dirty. I think before I do anything I've got to clean the thing. Yeah, transformer taps come around and go to this switch over here So this will be providing high voltages in these ranges here. So swapping that transformer, not trivial, because it will affect these. Unless I can get one that's got all these taps on it, which not going to happen. So I need to figure out what I'm going to do about that. At least it's intact. Does it work? I don't know. I'm going to give this a bit of a clean first. Get the worst of the dirt off it. And then we'll try powering it up. Off 115 volts, not 240. So I just started cleaning it. I've blown out the inside with like a brush. I've got airbrush. And it's not perfect. There's still a lot of corrosion and stuff around here. Like, there's a crystal there, it's corroded. It's probably not a good sign, but yeah, there's a lot of moisture in here. It must be a very humid environment this was in. But it's certainly looking a lot better. But the fact there's rust around the back here is kind of concerning, where it's in between these vents. Maybe water's got into it, I don't know, but I might take the circuit board out in the end and have a look and see what's underneath it. But I just started cleaning the front panel up to make it nicer to touch, and I've done about half of it so far. I don't even see the difference on camera about the bit I've cleaned and the bit I haven't. I don't know if it actually shows up, but I've done basically this half. I'll start working my way across. So clean it up, then I'll power it up and see what happens. Just want it nicer to touch, so it's not like grosser anymore. Well, I've got my variable power supply set up now, 115 volts. I'm going to plug this straight into the hoppy meter here, and we'll see what we get. I've put some tape around those bits of damage. There's actually 3 pieces on this cable. One there, another one just down here, which have got the insulation melted. So someone is not very careful. So I've cleaned the front panel up, so at least it's usable. But the fact there's rust in the back here is a little bit concerning. Might mean I need to take the circuit board out and inspect it, but we'll see what happens. We'll power it up and see if anything actually works. Right, switches off. Plug this straight in. Actually, I'll turn the power supply off, then I'll plug it in, turn the power supply on, nothing there. Okay, let's change views a little bit. Okay, let's see what happens. Well, we've got power, it's saying zeros. Okay, well, it's got some life. Leakage light comes on, value is coming on. Okay, well, it's doing something. I'm going to get a cable, hook up something and see what it actually does. Maybe the fact it's covered in grime and it is messing it up. So I found myself a 120 microfarad 400 volt capacitor. I'm actually wondering about slipping this thing back into the casing so I can see the screen a bit easier. Anyway, let's do a value first. 110 it says, so it's actually reading values. So I haven't done any calibrations. And I've got to set to small capacitors, let's go big capacitors. It's a big one, so it will take a while to charge. Just want to see what happens. This is where you have to hold the button down, you see. I'll set it to 100 volts. I'll just set to a low voltage and see what happens. Okay, well, even setting a low voltage isn't really doing anything. Let me just probe on this and see what voltage we're actually getting. Maybe the leakage test isn't working, which would be annoying because that's the bit I actually want to actually get this thing for, is the leakage. I would generate any voltage. Set to 25 volts. Yeah, it's doing 25 volts. Okay. $15. Yep. Let's go right down to the bottom. Right, start at the bottom. Let's do 3 volts. Yep, it's doing it. 6. It's actually did quite accurate. 10. Yep. 15. Let's leave the button pushed now, we're going upwards I suppose. 25. 50. Guess it's flashing because of the voltage, being dangerous voltage. But it's still not giving us an actual leakage value, is it? That part's not working. 100 volts. 200 volts, then I'll get this a 400 volt cap so I can do this. And if I release the switch it discharges. Yes, it does. Very quickly. So that part's working. So 200 volts, let's get in there. But it's not giving us a leakage value. 300 volts. Just want to see if it's actually going to do those levels. I mean, sort of 400 volts is probably the highest I'd ever go on it anyway. Just slowly getting there, 300 volts. Talk about a lot of energy at this sort of voltage. So it takes a bit more time to get there. But it's not giving us a leakage. So at least we know one of the symptoms we've got. Getting there, let's do 400 volts. Obviously this is as high as I can go with this cap. And it's kind of getting there. I just want to see if it sort of stabilises close to it. Obviously because of the leakage into charging up a big capacitor. But it looks like it's at least doing it. Yeah, it's getting smaller and smaller. So yep, that's there. Cool. So that's actually working. I don't know, let's just try doing a lead 0, see if anything changes here. Obviously this is me playing around with it, see what's actually going on. Lead 0, well it is basically 0. I'm seeing nothing there at all. So that's kind of useless. Inductance, again nothing there. Ring test. It's showing some ring. Showing 11 rings in this cable. Okay, so it's doing something. Inductance. Yeah. So the values in inductance are, well, now it's working. It worked for a second there. It did come back for a second. There. And I was banging it, there you go. So it's doing something. So yeah, maybe the switches just need a really good clean. Let's start with that. I know there's some people which will actually spend the time and actually dismantle the thing. Dismantle the switches, take the plungers out and that sort of stuff. Now there's a risk of breaking things and causing other problems by doing that. And I'm not saying that what they're doing is wrong, it's probably the better way of doing it, to be honest. But I'm too lazy for that. So I'm just going to spray around with some of this deoxit cleaner and it will wank its way into the switches. I'm just going to spray it onto these posts and stuff and it will work its way in. Just onto those posts and then I'll tip it upwards as well and try and get it into the front of the plungers and just try and get it all into all of them. Now we've got these switches as well, these sliding switches. I'm going to get into these. I can get into them like this. Alright, a bit in there, a bit in this one as well. Give those a clean up. Anything that needs cleaning is going to need cleaning because this whole thing's just gross, really. Right. It's old and it's probably been a bit of a rough environment. Maybe it's been in someone's shed or something, I don't know, but it's been sitting around in a really dusty environment and damp environment. I think it's probably been in someone's shed. That's what I'm guessing. But there was no bugs in it, so it can't be that bad. Anyway, let's just put some now into these plungers. So into the end of the plungers, and that should work its way down to the switch as well. Okay, and we'll work them some more. So basically I'm just going to just do this and try and clean everything and hope it comes right. Just doing this, I mean obviously I don't know for sure if it's clean, but putting some deoxit into all these switches is going to be beneficial. It's definitely going to need that. Now we've got all these adjustments on here as well which may or may not be problematic. You know, a bit of oxidisation, especially on the back here where it's got that moisture in there. It could have easily affected all these adjusters. I'm just going to do this first and then I'm going to do these other switches up here as well. Rotary switches. I'll come back once I finish cleaning. So I'll just spray some deoxit into all the wafers on this thing. And now what I'm going to do, I've got this little bit of machine oil. I'm going to put this into the mechanism. Just just a tiny little bit. This goes a long way, just to try and help it to move a bit better and not bind up. So when I first started doing this, this was feeling quite gummy, and it's definitely feeling a lot better. I could have used a thin oil, probably have achieved the same result, but anyway. Let's do the other switch, which should be a bit simpler because it's just a simple basic switch. Let's just spray some in here too. The gumminess comes from the shaft, so let's put a bit of machine oil in this. Again, we don't want too much, just want a little bit. Don't need to run everywhere. Try and get it to push down to where the shaft is. Right. Hopefully that will gradually work its way in. I may take the knobs off and put something on the other end as well, just so it works through a little easier. But that's the basics, I suppose. Now the next thing we've got is the oxygen fader. So we've got a trimmer here, well, got a pot here I should say. I need to get something there so I can clean that. And also you've got the trimmers, which I'm not going to do anything with yet unless I know I've got a problem with one. It's likely I will have problems with the ones at the back, like I said. They may even need replacing. We shall see. I'll address that one if I need to. Yeah, I mean they're tarnished, but they're not rusty, so they might be okay. The top board, this crystal over here, it's not meant to be rusty. So if something's not working, it's probably related to that circuit there. I'm guessing that's an oscillator, which is supposed to be generating stuff for measuring values and what have you. And we're not measuring values, are we? Well, we have measured value, but we haven't measured leakage. So what we can even do is just unplug all these connectors and reseat them. Sometimes that might fix stuff too. And yes, I'm kind of shotgunning because sometimes it's not worth sitting here working through a problem, spending hours and hours trying to narrow down where something could be, when you could just clean the connector and the problem goes away. Right? Technically you could say, oh, you're not really troubleshooting it, you're not really diagnosing it, you're not really fixing it because you're not going into figuring out what's wrong. Well, the thing is though, if you get some kind of weird obscure issue because you've got a bad connection somewhere, and it may be intermittent. So my philosophy has always been, do the basics, get everything cleaned up, get the connections all nice, so you can then ignore those as potentially being an equation. So then, if you've still got a problem after that, that's when you start digging. Otherwise you're wasting hours and hours potentially because you haven't unplugged that connector and plugged it back in again once. You know, sometimes that's what it takes. So yeah, that's why I do it this way. I clean things up and just see what happens after that. There's actually been plenty of times where just cleaning things and reseating things has fixed it. But that's all I needed doing. I didn't need to spend hours trying to figure out how a circuit works. So anyway, let's do this. That's the fader one. I want the other one. Spray some in there. And just reseat them. Because I think these have been sitting here for however many years. I'm not sure. I don't know when this one was built. You know, it's probably a good 30 years old. There's a sticker on the side, does that say? There's a date on that? Doesn't say a date on it. It would be nice if there was one somewhere. Maybe I'll find one. But yeah, having a date code would be nice to know when this is actually built. Either way, thankfully, ICs aren't in sockets, because if they're in sockets, you have to take each one out, clean it, reseat it. It does make replacement really easy, but not the way it's laying down like that either. I think they should be standing up. Yeah, I can resetting connectors, you don't necessarily do that. Right, now done that cleaning, let's see if anything has changed. Getting something here, I'll do a test though. Probably an adjustment for that. Let's connect this up and see if this is going to do anything different. Value 107, so it's still working. Leakage test, we're seeing 9, but that's what we saw before. I don't think this is working. treat it as an inductor. No, nothing. So that's definitely not. See, now it's getting something there. See that? Still don't trust these switches actually. Let's get an actual inductor. So I've got a random inductor. I've got no idea what value this is. It's just a filter for DC supplies. So don't know what's going to happen there. Let's try it. This is flashing for that. Let's try a larger value. I don't know. Flashing. Still flashing. Still flashing. Oh, did it do something? No. Okay, bring it back down again. Ring test. 0 rings. I don't know if it matters doing that. So I don't know. I'm not quite sure what's going on with the inductor part of it either. So it's got potentially a couple of issues there. One of which can't get the leakage, and the inductance isn't really showing up. I should try a different inductor. Alright, so I've got a 4.7 microhenry inductor. Well within the range of what this thing should be able to do. So we've got some rings on there, got 3 rings. Value. Still not reading it. So well, it's a digital problem where it's not quite always switching, or if it's the switches themselves. Yes, that's gone to nothing. Okay, so we've got some problems here. Doesn't read inductors. Doesn't read capacitor leakage. Right, so it's half works. I mean, ringing seems to work, value seems to work, just those other 2 don't. So let's just do some ripple checks and voltage measurements. We've got 3 big capacitors down here. Let's just see what we're getting on those ones. So I haven't read the manual, I don't know what I'm supposed to be getting anywhere. I just want to probe around and have a look. Let's turn that on, turn that on. And let's see what we're going across this one first. 25 volts. AC ripple's not looking horrendous. Don't forget, this isn't a switching supply, so it's going to be a bit better in that way. Frequencies will be lower, so it'll be easy to see it. 16 volts, nothing showing up on AC. Now this one down here, which is a bit tricky to get to, I think. Alright, that one there, and the wire goes into here. 11 volts with quite a bit of ripple there, 370 millivolts ripple. So that capacitor at the back there is definitely looking dodgy. The other 2 not so bad. There's a couple standing up off the board here, so let's have a quick look at these. 7.2 volts, nothing really horrendous. Okay, so I've got definitely 1 bad cap. The other 2 seem okay, but me being me, I'm inclined just to replace all of them anyway, because you just don't know. I like to replace them. And this is a piece of gear that I intend to keep. What I intend to do with bits of gear that I intend to keep is I'll basically completely replace them all. I'll go through capacitors and replace everything, and then I know it's done. It's going to be good for the next, 15, 20 years probably. Whereas right now, it might be okay now, but it could fail next week. You just don't know. So I've got my ESR 70 gold here out. I'm actually going to measure these capacitors and see what we're getting with this before I do anything else. There's also a couple other random electrolytics around which I might also just test. So I'll turn it on. So let's start with this one here. .687 microfarad, 0.2 ohms. That seems reasonable. I don't know what that capacitor is. Can't see the markings. Wish people would install capacitors with the markings facing upwards so you can read them. Alright, let's try this one. This one's also looking okay. We've got this one down the back here again. I don't know what this one is. Can't see it. I think I can just get onto that wire. Also measures okay. 2000 microfarad, but 0.2 ohms. Interesting, because this one here had a lot of ripple on it, so I'm surprised that one's actually measuring okay. Makes me suspicious, actually. Okay, so we've got this other one here. Let's measure these random electrolytics. 2.4, 2 microfarad. Okay, I thought I saw another one here somewhere. Here we go, just here. .7. What's on this side? Quite a few more. Some I can get to, some I can't. There's a big one here, look at the big one. That one just there. It's 100 microfarad, reading 89 at 0.6. Reasonable. There's one here which the heat shrunk back a little bit. I think I can get to the terminals on that one. 3.8 ohms, 1.9. Bit on the high side. I mean, there's 10 that I can see, plus the few on this side. So there's only like 15 or 16 capacitors I need to replace if I wanted to recap the entire thing. And here on the front panel, there's one on the front panel here as well. Let's check that one. It's a nice easy one to get to. 1.7 ohms. It's probably just local power supply smoothing. Can't see what it is. So I'm actually inclined just to replace every single capacitor in this unit, mainly because I want to keep it, and also because it's not behaving correctly. Many times you can fix something just by replacing capacitors. Many times. Where, you know, capacitor's marginal, it's putting a bit of noise, but it's too much ripple. Digital circuitry doesn't like the ripple, and therefore it causes weird sort of behaviour which is unpredictable. It's not an actual failure, it's just erratic. Digital circuitry really does not like ripple, so that's one of the reasons I like to replace capacitors and a lot of equipment as well, because of that. I actually might just go away and replace all the capacitors in this thing. Well, that was a bit more involved than I thought it was going to be, because there's actually wired links between these boards in here. So I couldn't just lift the boards up and take one board out, I had to take the whole pair out, which means I had to take everything off. Thankfully, everything plugs in. So I just got to make sure I don't miss anything when I put it back together again. But now, at least we've got the boards here, and I can unfold it and work on it. Just be worried about breaking wires and stuff, but actually have a look in the back, see if there's any issues I can see. No, it's actually looking right between the boards. Inside the sandwich. Because I had all these plugs here which I had to take off. And I was thinking, okay, I'll just unplug those and I can just lift it out. But no, you've got all these ones down here too. Why weren't those ones on plugs? Yeah, that was annoying. Maybe they used to be, maybe someone took them off because they didn't behave very well. But maybe it's designed so you can just open it up and work on it that way. Bit more involved than I thought, but that's okay. Anyway, now I can get on the recapping. So I've just taken this capacitor here out. And these pads aren't looking wonderful, are they? Look at that. It should be something on this side. And they're looking like there's basically gone. So, do you think that could be part of the problem? Top side pads have just gone because of corrosion. Those might need fixing up. So that could be an issue of these where the top sides, even here, is not looking right, is it? Just there. On that one there too. Top side pads could be a problem because it's been exposed. I hope not, because of that rust over there. It's not a good sign. Well, I just gave a bit of a brush up my little fiberglass brush just over here, and they've shined up again, so I actually think they're okay. Must have been a bit of tarnish on there, so maybe it's not such a big deal after all. That's the first capacitor done. Let's do the next one. Right, there's also silicone down to the board. I'll have to cut through that. There we go. Right, 1000 microfarad 25 volt. Let's clean these pads up as well. So figure out where I'll put my brush. Because I'm going to try and solder these from the top side as well as the bottom side, because I think that's a good thing to do. I don't like to rely on the wires. The wires are sometimes not the best, you know, the actual through-hole plating. Don't like to rely on those. I always prefer to have actual solder joints running right through the board onto the pads. So 1000 microfarad 25 volt, 1000 axial, 25 volt 1000 microfarad. Chuck this one in, get the polarity right, and I'm going to spin it so you can see what the values are as well. I'll also glue these down when I'm finished as well, just like the originals were. These ones seem to have connections on the top as well, so I need to do both sides. This one's on the bottom this side because of the ground plane there. And it's to the top side as well. Try and get it to flow across onto the trace. So like I said before, I was relying on the via and the through-hole plating. I really don't like to do that. I always prefer to have it going directly onto the pad. Down there it's not actually looking like it's soldered very well, or at all potentially. Same as that one there. So some of these wires aren't even done very well. Those will need doing, I think. There's like nothing on the top side here. As long as it's soldered properly on the bottom it might be right, but even those don't look great, and that's factory. Clip those off. What worries me a bit is this holding open and shut. I'm worried about breaking these wires. A bit blobby on this side, but it's flowed through. Let's take a bit of that off. Just tidy it up slightly. So I just noticed just around here, it looks like it's got a bit wet. See a little bit of corrosion just there. It's like a little bit in this area, but just there. Should give that a bit of a clean, shouldn't I? That may be something we have to worry about. Could be bridging it slightly and just causing issues. Sometimes giving it a brush is all it needs. Yes, yeah, that's looking alright. It's just a bit of residue there. It's like I had like a little droplet or something get there at some point or something, I don't know. Well, it could just be environmental. Yeah, it's looking better. That's fine. I think I might have to inspect this whole board really closely to make sure it's okay. So I've now fully recapped it, replaced every single capacitor. I'm going to go through in a second and check all the caps and see what we actually got. I know I did check some randomly and some are quite bad. Let's try this again. Turn it off now. Turn this on. And see if we get any magic smoke. If I've got anything in backwards. I hope not. Let's put in 12 watts. We have a 9 on display. Okay. And let's actually test one of its own capacitors. How's that? Let's get a smaller one. Maybe not that one because I dropped it on the floor and lost it. Let's get this one. Let's just try to see if it actually works or not. So you can't see this because my hand's in the way. Zeroing still isn't working. Anyway, what's this thing rated for? This is a 63 volt cap. We'll see what happens when we get this hooked up and see if we can actually see a value or not. Say minus 2.4. Okay, let's try leakage. Don't think leakage is doing anything still. So you haven't actually solved any problems with the looks of it by recapping. Let's short the leads together and do value of inductance. That says 10 as well. And adjust the knob. That's just 2.1. All the way the other way. Okay, so the knob is doing something. So inductance is actually doing something. That's 0 on inductance. Capacitance. Says minus 2.4 all the time. So we've got it set for inductance, but capacitance isn't working, so I need to look into that part of it. But the fact that we're saying minus 2.4 there, regardless, let's try a bigger cap, something a bit more measurable. You know, there's a 1000. See 1000 on it. So it is measuring something. It's just completely out of whack. But at least it is reading, after all. Do a leakage on this one. That's the same as before. It wouldn't actually go away. High voltage. Same, won't go away. And what was this? This is a 25 volt cap, so yeah. 10 volts. Yes, no changed at all. So that hasn't changed at all. The leakage still isn't working, but at least we've got brand new caps in it. The inductance one, I don't know, where's that inductor gone? Let's try and measure that inductor again. We've zeroed it already. Stick this on the inductor and see what we get. Oh. 7.7. So it is working. Ring test 3 rings. The leakage is still not working right, so we need to look at that one still. So it's still not fixed, but I'll go through the calibration process as much as I can, and then we've still got that one fault to fix.